All right, question 2b, part 2. It says, in relation to the graph, fully describe the point where the tangent meets the graph. So we're looking at this thing here, and we know certain things about it. We know that when x is 1.5, the gradient is 0. So that must be a turning point. We also know it turns at 18. Sorry, not turn it crosses the x-axis. So it's going to look something like this. So it's going to cross. So we've got, I'll try and draw as best I can. Here's a 0. Here is 1.5. Yeah, I'll just put 3/2. There's 3/2. This is my x value. Here's my y value. Now, we know it crosses when x is 0, y must be 18. So it must cross, and I'll put 18 here. That's 18. That's 18, that point there. We also know that when the gradient is 0, y must be 15.75. So I'm going to call this point here 15.75. And then we have a straight line going across there. There's our line. And we know that coincides with this point here as the minimum point, and it goes through there. So the graph must go through there, turn there, and head back up like there. Yeah, that's what we're looking at here. So this is the graph. I'll write y is equal to x squared minus 3x plus 18. And this is y is equal to 15.75. So the turning point, why don't we say line y is equal to 15.75 intersects at the turning point, which is going to be 3/2, 15.75. And that statement there pretty much covers what's kind of going on here. More than that, I don't know if I can really add anything else. You probably want to set a minimum though as well. So turning point is a minimum. And if you wish to prove that, you can. I don't think you need to, but if you want to, you can. You can say check turning point, or why don't we put check nature of turning point would be a better thing to say here, okay? Check nature of turning point. So let's do that now. So we're going to have g double prime x is going to equal to 2. Yeah? As g double prime x is greater than 0, turning point must be a minimum. And that's how I would conclude that question.